2024 A-Level Combined Mathematics Paper 1 Part B, question number 17, Part A. Parts B and C of the same question will be discussed in future videos, links in top right. Part A of this question has to do with trigonometric identities and solving trigonometric equations. The question says, express 6 times cosine of 2x minus 8 times sine of 2x in the form of r times cosine of 2x plus alpha, where r is some value greater than 0 and alpha is some angle in between 0 and pi by 2 radians. The question then says, hence, solve 6 times cosine of 2x minus 8 times sine of 2x equals 5. Now after this the question says, express 24 cosine squared of x minus 32 sine of x cosine of x in the form of a times cosine of 2x plus b times sine of 2x plus c, where a, b and c are all elements of real numbers which are constants to be determined. Now finally the question says, deduce the minimum value of 24 cosine squared of x minus 32 sine of x times cosine of x. Now to start off with this question, we need to take this expression right here and convert it into the form r times cosine of 2x plus alpha. Now considering this expression right here, we can see we can express this in a different way by simply expanding the cosine. As we know, when you have cosine of one angle plus another angle, it is equal to cosine of the first angle times cosine of the second angle minus sine of the first angle times the cosine of the second angle. Now according to that, this thing can be expanded into r times cosine of 2x cosine of alpha minus sine of 2x sine of alpha. Now from our expression that we have here, we can see we have cosine of 2x times something, and we also have the minus and the sine of 2x times something. But what we need to do now is to convert this something and this something into cosine of alpha and sine of alpha respectively in order to get the form cosine of 2x times cosine of alpha minus sine of 2x times sine of alpha. Now in order to do that, we need to consider what kind of triangle would have the ratio of 6 to 8 in its side length when you have a 90-degree angle. So considering that, if we just draw a 90-degree triangle here, we can see if we take the ratio of these two sides to be equal to 8 to 6, then we can see if we draw the hypotenuse here would have a length of 10. This is of course due to the fact that the hypotenuse is going to be the square root of 6 squared plus 8 squared. 6 squared is 36, 8 squared is 64, adding 36 and 64 gives us 100, and the square root of 100 is 10. So therefore we have this. Now since we want the term that has a 6 to be the cosine value, we need to make it such that the alpha angle is such that the cosine of alpha is related to the 6. So according to that, the alpha must be over here. Now considering this, we can see cosine of alpha here is equal to 6 over 10. And similarly, the sine of alpha here is equal to 8 over 10. So according to this, we have a size of 10, which is hypotenuse, which we need to take out of this expression in order to get 6 over 10 here, which we can convert into cosine of alpha, and we can do the same thing with this 8 divided by 10 to get sine of alpha, and then we will have the form that we want, cosine of 2x times cosine of alpha minus sine of 2x times sine of alpha. So according to that, what we need to do is to divide this whole expression and multiply it by 10 in order to get the terms that we want. So according to that, if I go down, I can write 6 times cosine of 2x minus 8 times sine of 2x, and what I can do is to divide and multiply by 10 and say this is equal to 10 times 6 divided by 10 times cosine of 2x minus 8 divided by 10 times the sine of 2x. Now in this case, we can see since we multiplied and divided by the same number, nothing actually happened to the value. It's the same exact value, but now we have 6 over 10 here and 8 over 10 here. Now we can see 6 over 10 is equal to cosine of alpha and 8 over 10 is equal to sine of alpha, and therefore we can convert this into 10 times cosine of alpha cosine of 2x minus sine of alpha sine of 2x. Now as we know, when we have this form cosine of a cosine of b minus sine of a sine of b, it is equal to the cosine of a plus b. According to that, we can see we are going to get 10 times the cosine of the sum of these two angles, which is going to be alpha plus 2x, which I'll write as 2x plus alpha. And we are done with that. Now we can see this is the form that we wanted. We have 10 at the front, which is the r here, but for the alpha here, we've just substituted alpha. Now in order to actually find alpha, we need to find a relationship for alpha from this thing right here. Now in this triangle we can see, if we take the tangent of alpha, tan alpha is equal to 8 over 6, which if we simplify, we can write it as 3 over 4, or rather 4 over 3. So tan of alpha equal 8 over 6, which is 4 over 3, and according to that, since alpha is in between 0 and pi by 2, we can see that therefore alpha would be equal to the tan inverse of 4 over 3. So according to that, going down, we can see r, the value that we wanted, is equal to 10, and alpha is equal to the tan inverse of 4 over 3. And we can say another thing here, we can say because alpha is in between 0 and pi by 2. Now, of course, if it wasn't in between 0 and pi by 2, then we couldn't directly take the tan inverse. You would have to do, add a pi by 2 or do subtract pi by 2 or something in order to get that. But since tan or rather alpha is in between 0 and pi by 2, we can directly take, if tan alpha equals 4 over 3, then alpha equals tan inverse of 4 over 3. And with that, we have our answers, r equals 10 and alpha equals tan inverse of 4 over 3. Now, after that, the question says, hence solve 6 times cosine of 2x minus 8 times sine of 2x equals 5. Now for this, we can first write 6 cosine of 2x minus 8 sine of 2x equals 5. Now after this, using what we know, we can substitute this expression that we had over here instead for this expression. So here we can see we have 10 times cosine of 2x plus alpha. So substituting that in, we can see we have 10 times cosine of 2x plus alpha being equal to 5. Now according to that, the cosine of 2x plus alpha is going to be equal to 5 divided by 10, which is equal to 1 over 2, which is also equal to the cosine of pi by 3. Now according to this, we have the cosine of one angle being equal to the cosine of another angle. Now given the situation, we know if we have the form cosine of A equal cosine of B, then surely A equals 2n pi plus or minus B. So according to that, we can see our expression turns into, if we take this cosine of A equals cosine of B, we can get A, which is 2x plus alpha, being equal to B plus or minus, which is going to be pi by 2 by 3 rather, plus or minus, and 2n pi, where of course n is an element of the integers. Now simplifying this down, we can see if we take the x by itself, when you take an alpha to the other side, we can also divide by 2, and if we do that, we're going to get x equals, this is going to be divided by 2, is going to be n pi, this is going to be divided by 2, is going to be plus or minus pi by 6, and this thing taken to the other side is going to be minus alpha divided by 2, is going to be minus alpha over 2, and hence this is going to be our answer, of course, for n element of the integers. So with that, we can conclude our answer here, and by the way, you don't need to substitute in the value of alpha as tan inverse of 4 over 3. Since we've already established that up here, you can use that value and we don't have to substitute it in here. Of course, if you substitute, you're not wrong, but it's much easier to just write alpha instead of the tan inverse of 4 over 3. Now with that, we are done with the solutions for 6 cosine of 2x minus 8 sine of 2x equals 5. Now after that, we can move on to the next one, which says express 24 cosine squared of x minus 32 sine of x times cosine of x in the form of a times cosine of 2x plus b times sine of 2x plus c, where a, b and c are real numbers to be determined. Now going down, if I write down this expression, we have 24 cosine squared of x minus 32 sine of x cosine of x. Now considering this expression here, we should immediately see that we have sine of x come cosine of x, and as we know, the sine of 2x is equal to 2 times sine of x times cosine of x. According to that, if we take a 2 out of this 32, we will have 16, but then we'll also have a sine of 2x. Now given that, we could also say sine of x times cosine of x is equal to sine of 2x divided by 2. So the first thing I'm going to do is to substitute for this 32 sine of 2x times cosine of x, minus 32 times sine of 2x divided by 2. Now similarly, for the 24 cosine squared of x, what I'm going to do is to use the fact that I can write the cosine of 2x as being equal to 2 times the cosine squared of x minus 1. And of course, according to that, if I rearrange, I can see cosine 2x plus 1 is going to be equal to 2 cosine squared of x, and therefore cosine squared of x is going to be equal to cosine of 2x plus 1 divided by 2. So according to that, if I substitute in, I can write this as 24 times cosine of 2x plus 1 divided by 2. Now with that, I have my expression in terms of cosine of 2x and sine of 2x. So I can write an equal sign here, and I can simplify this down, and simplifying down we can see the 24 and the divide by 2 cancel, leave us with 12 here. So we have 12 times cosine of 2x plus 1, which is going to be 12 cosine 2x, and I'll take the other 12 to the front here, and then we're going to have minus 32 over 2, which is going to be minus 16 times sine of 2x. So we have 16 cosine of 2x minus, or rather 12 cosine of 2x minus 16 sine of 2x plus 12, and therefore our expression is 12 cosine of 2x minus 16 sine of 2x plus 12. Now considering our expression above here, we can see we needed a, b and c, where a is the coefficient of cosine of 2x, b is the coefficient of sine of 2x, and c is the coefficient of the constant term. That's not, of course, you wouldn't say the coefficient of, c is the constant term. I believe that's the better way to say it. So given that, going down we can see in our form here, we have a equals 12, b equal negative 16, because of course we had plus b in our original expression, and c equals 12. And these are the answers that we have in our expression. Now going up, with that, we can finally move on to the last part of the question, which says, deduce the minimum value of 24 times cosine squared of x minus 32 sine of x times cosine of x. Now going down, if we consider the expression that we have here, we can see our expression, which is 24 cosine squared of x minus 32 sine of x cosine of x is equal to 12 cosine of 2x minus 16 sine of 2x plus 12. Now usually in these problems, the first part of the problem is somehow helpful for the second part of the problem. In this case, going up, we can see what we found in the first part of the problem was that 6 cosine of 2x minus 8 sine of 2x is equal to 10 times cosine of 2x plus alpha. Now according to that, we can see if we take a factor of 2 out of this bit here, we are going to get 2 times 6 cosine of 2x minus, and if we take a 2 out of this thing, this is 16, dividing by 2, we get 8 sine of 2x plus 12. Now going up for a second, we might notice that this thing right here, 6 cosine of 2x minus 8 sine of 2x, is exactly the expression that we had in the first part of the question. And given that, we can see instead of that expression, we can substitute in the expression 10 times cosine of 2x plus alpha. So according to that, we could substitute instead of this thing 2 times 10 times cosine of 2x plus alpha, and then another plus 12 on the front. Now given this, we can see we have 20 times cosine of 2x plus alpha plus 12. Now you might be asking at this point, well, alright, we got this expression, but how does it help us find the minimum value of this entire expression? Well, you see, in this thing, we have a constant term and a single trigonometric function. And we know the exact bounds of this trigonometric function. This trigonometric function is cosine of an angle, and therefore it can only go in between -1 and 1. So according to that, the minimum value of this expression is going to be -1. So we can say the minimum is -1. So since this is a constant term, this doesn't do anything, but this term is minimum at -1. According to that, the sum of these two terms, which is what we want to find the minimum of, is going to occur when the inside of this thing, cosine of 2x plus alpha, is equal to -1. So according to that, we can say, therefore, the minimum of the expression we had of 24 cosine squared of x minus 32 sine of x cosine of x is going to occur when this internal value becomes equal to -1, in which case we can see we get 20 times -1 plus 12, which is minus 20 plus 12, which is equal to -8. And therefore the minimum value of our graph is going to be equal to -8. So with that, we have finally completed the last part of the question. Now we can go up and discuss all the marks awarded for this part of the question. So at the start of the question, when you use the triangle that you need in order to find the correct value of alpha and find the cosine of alpha and sine of alpha like so, you get 5 marks for that. After that, when you take this expression and multiply and divide by the hypotenuse, which is 10, in order to get 6 over 10 and 8 over 10 that you can substitute with the cosine of alpha and sine of alpha respectively, you get 5 marks. When you then do that substitution like so and get cosine of alpha times cosine of 2x minus sine of alpha times sine of 2x like so, you get 5 marks. And when you use the fact that cos A cos B minus sine B is cosine of A plus B like so, you get another 5 marks. Now after that, when you then correctly identify the value of r as 10 and the value of alpha as the tan inverse of 4 over 3, you get another final 5 marks for that. After this point, when you then use this equation and substitute in the expression that you have in order to get 10 cosine of 2x plus alpha equals 5, you get 5 marks. When you divide both sides by 10 and say that this is equal to a half, which is then also equal to cosine of pi by 3, you get another 5 marks. When you then apply the fact that if you have cosine of a equal cosine of b, then a equals 2n pi plus or minus b, you get 5 marks for that. And finally, when you rearrange everything to get x on its own and you get this expression right here, you get another final 5 marks for that. Now after this, for the second part of the question, when you take this expression and substitute in this identity for cosine squared of x as cosine of 2x plus 1 divided by 2, you get 5 marks. And similarly, when you substitute the identity for sine of x times cosine of x as sine of 2x divided by 2, you get another 5 marks for that. Now after this, when you simplify and get this expression, when you use that to find the values of a, b and c as follows, you get 5 marks. And when you use this equation and do this substitution and simplify this expression down to this expression 20 times cosine of 2x plus alpha plus 12 and find that the minimum is equal to -1, you get 5 marks. And when you substitute this minimum of -1 to this expression and get 20 times -1 plus 12 and finally get the final answer of -8, you get a final 5 marks for that. And with that, our discussion of this question is finished. So I hope you enjoyed. If you have any feedback, post them in the comments down below. Thank you for watching and goodbye.